We're really excited that you're all here. What you're about to witness is the hard work and passion of 14 teams as they worked through all of IAP to create the robots that you're going to be seeing today. Before we get started with the contest, though, I want to talk a little bit about what Maslab is and what the contest rules are. So Maslab, our key feature is that our robots are autonomous. They run completely by themselves without any sort of human intervention. Number two, they're vision-based. Their key feature is a webcam, and using this webcam, they will find the red balls that you see on the playing field and deposit them in through these yellow mouse holes. Third feature of Maslab is that the playing field is unknown. So the teams have not seen this playing field before today. The robots have not experienced this playing field at all until they put down their robot and set it to run. So their robots need to be very robust. They can't just program themselves for one eventuality. They need to be able to deal with new and different situations. So in summary, our robots are autonomous, vision-based, and they navigate in unknown playing fields. So this year, the specific goal of our contest is as follows. You'll notice that there are red balls on the playing field. There are 12 of them. And teams get points for putting these balls through the yellow mouse holes. Now, we want to encourage teams to put balls in multiple different mouse holes. And therefore, teams get 6 points for the first ball that's placed through a particular mouse hole. They get 4 points for the next ball placed through the same mouse hole, and 2 points for any remaining balls. That means if you have 2 balls and you put them both in the same mouse hole, you'll get 6 plus 4 equals 10 points. However, if you put them into 2 different mouse holes, then you'll receive 6 plus 6 equals 12 points. Those are the red balls. Now, there's also one green ball on the playing field, and this ball is called the power ball. You'll notice it sitting in the, on the left side of the playing field up there. Now, if the team can pick up this green power ball, this bonus ball, and put it through the bonus goal, which is marked over here with the green, black, green barcode, they get additional points. Now, if they can do this super fast, within 30 seconds, they get 12 points for scoring this goal. If they can do it in 45 seconds, then they get 8 points. And if they can at least correctly identify which goal the green ball should go into, then they receive 4 points. The power ball does not receive any points if it's placed in any other goal, except for this goal sitting in the corner over here. And again, this is to encourage teams to use mapping and try to plan out their movement instead of just wandering randomly around the field. Now, we also want to reward teams for simply picking up balls, because even finding targets is not an easy task. So if at the end of time, at the end of 5 minutes, if a team has a ball in its possession, then it receives 1 point. And possession is defined to be if we move the robot, then the ball also moves with the robot. Now, we also want to reward teams that try to score in a mouse hole, but it doesn't quite make it in. Because, again, aligning yourself to a mouse hole is a very difficult task. So, if a team deposits a ball and it's on the porch, which is defined to be a 14-inch squared area, 14 inches square area in front of the mouse hole, then they receive 1 point for that as well. So that's all of the scoring. And teams have 5 minutes to run their robots. The robots must start at the push of a button, and after 5 minutes are up, the robot must stop on its own. Now, this is a very difficult contest to actually do. And thus, there's some key aspects that make it possible. First of all, the Maslab philosophy is that this is a research quality type of problem that teams are trying to deal with here. I mean, sure, the field is simplified. We've told the teams know that the carpet is going to be this blue shade. They know the walls are going to be white. They also know that on top of the white walls, there's going to be a blue line. And the blue line is there, so if you're wearing a red shirt in the audience, the robot won't think that you're a ball and try to go at you. So we do provide things to simplify the contest, but it's still a pretty difficult task. So we encourage teams to work together. And what you're seeing here, yes, there is a prize for first place. And yes, we will have an engineering award given out to a team that displayed some very cool engineering but may not win first place. But it's also an exhibition. It's an exhibition of what these teams have accomplished over this month of hard work. And we encourage teams to work together while they're in lab, to cooperate. Teams keep daily journals of what they do and share ideas with each other. And so what you're seeing here is not just a robot that 3 people put together, but a robot that was produced, or a set of 14 robots that were produced by 50 people working together in groups on their own robots. Now this contest would also not be possible, or would be very difficult to do without the right parts. And for this, at the beginning of IAP, the teams are given kits of parts that include a full computer, it's a 733 megahertz processor, a webcam. They're also given various sensors as they need them, and we have a small shop for them to build their robots. And we also give them geared motors, so they don't have to worry about, or they have to worry less about driving issues. We really want them to be able to put a robot together, get it moving, and then start testing out their software and whatever innovative ideas they want to do in terms of ball gripping mechanisms, scoring mechanisms, things like that. And as you can imagine, all of these kit parts are super expensive. And thus, we are extremely grateful for our sponsors. We have here tonight ITA Software, which are our primary sponsors. You guys will please stand if you're here from ITA. We also have our silver sponsors here, Google. And we are also sponsored, silver sponsored by the Ray and Maria SATA Innovation Fund, and we receive some funding from MIT Course 6. And we are extremely grateful for these sponsorships. In addition to these monetary sponsorships, we also receive part sponsorships from a number of sponsors, which are featured up here. Altera donates chips for us to use on our controller boards, which are designed by the staff for the contest. Analog Devices provides us with the gyros. Is a member of Analog Devices here? If you'd like to raise your... Yes. No, that's okay, sorry. Okay, probably will be here shortly. We also get donations from APC, Cables Unlimited, Click Automation donates our motors, Crystal Fonts donates LCD screens to us, DigiKey, you probably all heard of, ICP helps us out with computer hardware. iRobot has donated very graciously a Roomba that will be raffled off in addition to some other things. And we're also grateful to MIT Copytech, who makes it possible for us to create posters like the one you see up there.